Hello, everybody. Welcome to the joint webinar of ICRON and CQM. Our talk today will be about algorithms and their importance in optimizing decisions in various business processes. Today, I am honored to share the stage with two professionals in this field, two leaders in this field, Associate Professor Ali Tamer Ünal, founder of ICRON, and Dr. Jan van Doormalen, partner at CQM. So, who is ICRON and who is CQM? ICRON is a leading solution provider for advanced planning, scheduling, and optimization with its unique technology that has been developed over 25 years. With more than 500 implementations worldwide. ICRON is based in Amsterdam, Netherlands, and there is R&D office in Istanbul and offices in Singapore and Kuala Lumpur. CQM is founded 40 years ago. CQM is an expert group of consultants in quantitative modeling. It is based in Eindhoven, Netherlands. CQM is specialized in optimizing planning and logistics in combination with data science and smart analytics through its top-notch designed algorithms. ICRON and CQM has a long-lasting partner relationship for more than a decade. And during this duration, many planning and optimization projects were tackled by ICRON's technology on one hand, and CQM's consultancy experience, modeling experience, expertise on the other hand. So some general instructions about our webinar today. All participants will be muted. There will be a Q&A session at the end of the webinar. We highly encourage you to ask your questions through the chat window during the session. I will be collecting and reading the questions at the end of the webinar, and hopefully we will answer these questions at the end of the webinar. You can customize the view of the webinar by making the presentation part or the video cam part bigger or smaller. We will record the webinar, and the webinar, the record will be shared with all participants tomorrow. So, technology, as we all know, is at the core of many discussions, many political, social, and economical discussions today, due to the ease, flexibility, and speed it provides to our daily lives, and also the power it possesses in terms of data creation and processing the data every day. Algorithms, on the other hand, is a vital part of this discussion. Considering the decision-making and optimization part of this discussion, my first question is to Tamer. Where do you think the value of algorithms in decision-making? Can we replace Excel spreadsheet formulas, and why?
Okay, thank you very much, Barış, for the nice introduction. I will first give a very boilerplate answer to this question, a simple one, and I will later on try to explain what I mean by that. Algorithms for us are the primary tools that we utilize to make optimized operational and tactical decisions and make this decision-making process consistent in time. I will explain what I mean by this consistency and optimization. But before starting with algorithms, let me give you my take on what data means and how we see data play a role in algorithms. Data is a digital recording of real life. So if you think about a supply chain organization, by data we mean the information regarding inventory levels, organizational capabilities, current commitments to existing customers like sales orders and relations, current relations with customers, recording of customer behavior, past customer behavior, and market conditions, etc. Now, algorithms, so the data is sort of a representation of the organization or the system or the company in time up to current timing period. Now, when we look into algorithms, when we get into algorithms, algorithms are actually organized calculations which are mostly based on the data that exists in the organization. So they use the available data as necessary and calculate various aspects regarding the business. And in the supply chain context, algorithms play a number of crucial roles. I will try to categorize different types of possible algorithms that are used in real life. The first use of algorithms in an organization is to commonly look into data and detect patterns and possible explanations in the data. So to understand, in a respect, to understand where we are as an organization. So we need to see what the state of the system, what the state of the company at that particular moment is, and algorithms help us to visualize the current state. So these kinds of algorithms are called descriptive algorithms. They are usually used within reporting systems or simulation systems, etc. But if you need to actually make judgment calls on the current state of the system, like are we doing okay, and what is our state in response to or in correspondence to our competitors, etc. So if we need to make judgment calls regarding our current state of the system, our current performance, then we can consult to diagnostic algorithms, where they look at the descriptive nature of the system, and then they make judgment calls regarding how we are performing. So it's not just what we are doing, but also why and how we are doing at the current moment. One additional set of algorithms that we normally utilize in organizations is not interested only in the current state of the system or the historical perspective on the organization, but based on this current state and historical state, these kinds of algorithms are used to generate estimations regarding what the future may look like. So these kind of algorithms are called predictive algorithms. So they actually make estimations regarding possible future states for the organization. For example, demand forecasting algorithm can be viewed as a predictive algorithm. It actually tries to predict what's going to happen in the future. Note that all these algorithms that I mentioned basically represent mathematical calculations, and they normally improve the visibility and control of the organization. So I can actually, if I use these types of algorithms in my processes, then I can actually have more visibility and more control on my processes. On one hand, they have the ability to crunch large numbers, these algorithms, but on the other hand, maybe more importantly, they actually include a model which actually captures an inherent digital model of the organization, of our organization, and the environment that we operate. So they actually possess the logic and dynamics of the system that we actually have on hand. I think proper utilization of these analytical algorithms is imperative for today's organizations to survive, to start with. But I believe that the most significant positive impacts on the overall performance of an organization can be achieved if the final decisions made in the organization that translate into actions, for example, purchasing, sales, the actual action of production, etc., are based on concrete, repeatable, efficient, and controllable processes. So it's not just our aim to understand what the system is, but we also need to be able to control it and guide it in optimized actions. So here comes the fourth set of algorithms that we call prescriptive algorithms that plays the role here. These algorithms capture the dynamics and the logic behind the actions we take and decisions that drive those actions. So they do not only help us understand where we are, how and why we came here, and how we are doing, etc., but they also tell us the best course of action so that we attain a sustainable, profitable, and competitive business. And these algorithms are called prescriptive algorithms. And usually in decision-making processes, we actually utilize these prescriptive algorithms to the full extent. Let me give you an example. Or maybe I can leave it here so that the discussion goes on and we can come back to examples later on.
Sure. Thank you, Tamer. Actually, as you rightfully put, there are many different types of algorithms. And one of the dilemmas for decision makers is how to differentiate from good versus the other part. So my next question is to Jan. Jan, you have worked on zillions of algorithms during many years of experience in this field. So what do you think makes a good algorithm?
Thank you, Barry, for this intriguing question. But let me first start that it's really a pleasure to have the opportunity to be in this webinar, that we can share our passion, because that's in fact what we are doing here. It is our passion together to optimize the decision making, and at the core of that is a good algorithm. Tamer already explained what algorithms are and the different types of it in the environment. And now, what makes an algorithm good? I think there are many things, and I would like to emphasize a couple of them. First, of course, an algorithm needs to be fit for purpose. And fit for purpose is that it needs to be aimed at the decision that has to be taken. And so when does that decision have to be taken? What does it encompass? So what's the scope of the decision? Who has to do it? And what's needed to make that decision? And so that's the fit for purpose question. It's a very important one. The next one, the second one is it must be as simple as possible. Not too simple, of course. That's always then the dilemma. That's the catch that you have. But it's very important that you really focus the algorithm on the question at hand, and that's a modeling. That's in fact a modeling question. The other one is, and that's for the users, it needs to be fast. Because basically what is happening is there is a decision maker. He needs to make a decision, and very often, especially when it's an operational decision, he has to make it fast. The environment is changing. There is new information available. What should I do? And that needs to be done fast. So speed is a very important aspect as well. Then a very important one, and that's a difficult one in most situations, that needs to be explainable. And what do we mean with that? And so we have an algorithm, it transforms certain data in other data, and we have to make a decision based on that outcome. But do we understand what that algorithm is doing? If we do understand what the algorithm is doing, we most probably also will then trust the outcome of the algorithm. If you do not understand the logic behind it, or that is what is happening in the black box or the gray box or whatever you would like to call it, then the user might have an issue with trusting the outcome of the algorithm. The next one, also a very important one, is adaptability. An algorithm must be robust for changes in the environment. And so if we have, for example, in the supply chain, if we have new products, it must be easy to introduce those new products. If you have new equipment or changes in the equipment, it must be possible to put that new equipment in the environment and work with it. If the costs are changing, you must be able to do something with it. If you have new suppliers, it must be easy to insert them into your system. It must also be easy to tune the algorithm to the new insights that you might get. For example, your company is in an environment that is changing, so you need to change your objectives. Is it easy to change your objectives in the algorithms? All those things are very important. And there's a last one, and that's, I think, not one that is particularly seen by most people in the supply chain, that is fairness. That's an ethical topic. Of course, there's a lot of discussions around it, because fairness is a very important thing. But I also think that in the supply chain, where people do not really think very often about this, it has a certain value to think about fairness. For example, how do you distribute your purchasing orders over your suppliers if you have more of them? But also on the other end, at the other end of the supply chain, how do you distribute your end products to your different customers in a fair way? You should really ask yourself these questions. This is, I think, a bit of a summary of what I think are the most important things. There are many other things, of course. But there's one other thing, Baris, if you allow me some time, that is very important when we talk about good algorithms. That is not the good algorithm itself, because you can have a very brilliant algorithm, in fact, so built by the best mathematicians and information scientists, and being worked out by all the good people that you have in your company. However, we must think about the garbage in is garbage out principle. So if you do not have your data on order, so if you don't have accurate and timely data, then however brilliant your algorithm is, it will not give you the results that you would like to have. So sloppiness there will prevent you from creating business value. On the other hand, what I also see is as a pitfall is perfectionism. What also might happen is that you think, okay, well, my data need to be accurate into the last 10 digits, let's say, and we need to do everything in good order. That is also, of course, a difficult thing, because then you will never come with a decision at all. This, Baris, is what I wanted to tell there.
Thank you, Jan. So actually, I myself, as an algorithm developer, have some takeaways from your experience. So actually, to sum up, the algorithm should be purposeful, as simple as possible to serve the purpose. As I understand, it should be fast. very important, especially in today's life. Explainable, explaining what the algorithm proposes as an output. Flexibility, future-proofness, and the fairness. It's actually another very interesting topic that you raised over here. And technology is seen as an enabler for making a good algorithm within this framework that you define. My next question is, I would like to direct to Tamer. As a technology developer for many years, actually for more than 25 years, which is the algorithmic tool or set of tools to use to optimize a particular decision process?
Okay, thank you. Following Jan's arguments, I would say I would start by saying that, as Jan mentioned and you mentioned also, every algorithm that you develop is actually based on certain assumptions and expectations. For example, Jan mentioned about the importance of data. The reason most probably is that the algorithm requires a certain set of data to be able to work properly. And if you don't satisfy that expectation of data, for example, then the algorithm would be useless. It's not just the data actually, but algorithms make assumptions regarding what kind of problems they can address. So every algorithm has a determined fixed set of parameters and environments that they can operate in. Let me give you a very simple example. We have a very famous algorithm called the simplex algorithm. I'm sure anyone who dealt with algorithms knows the simplex algorithm, which solves optimally the linear programming problem. And this simplex algorithm is actually most probably one of the most frequently used algorithms in real supply chain problems, solving in real supply chain problems. But even though it is such a successful algorithm, it is based on certain assumptions. For example, one of the most restricting assumptions for the simplex algorithm to generate the optimum solution is that whatever decisions that you are making based on this algorithm, they should not include any integer value. It is a simple assumption, very actually maybe even not significant looking. But for example, this makes a problem like assigning people to tasks being unsolvable by that particular algorithm. So you cannot solve the employee assignment problem if you cannot assign half people to tasks. Then you need to assign integer number of people to tasks. Then you cannot actually use the simplex algorithm. So actually, since every algorithm is based on certain assumptions, expectations in regards to data and the attributes of the problem, there are as many algorithms as there are problems, actually. So it is very difficult to say, as an answer to your question, it is very difficult to say or impossible to say that these three algorithms are actually the best algorithms to solve all supply chain problems. So basically, what we know that most problems in supply chain planning are mathematically challenging, and they require special algorithms to solve efficiently to optimality. And unfortunately, all of these algorithms have specific limitations. And if you do not obey those limitations, those algorithms will not worth their value. So it is a little bit grim in that respect. But having said that, I believe that as supply chain planning practitioners, we are supply chain planning practitioners. The classical academic definition of supply chain planning problems should not be our primary concern either. We don't care if, for example, the scheduling problem is a very difficult problem mathematically, and we have thousands of different ways of solving these problems for thousands of different types of scheduling problems. We don't care about those things. What we care is, or what we should care is, we want to make real life decisions to operate in our real life environment, in our company. So we have only one instance of a problem. And that instance needs to be solved in an optimal manner. And I will be using the solutions of that single instance problem. And that problem needs to be solved efficiently. So rather than picking out-of-the-shelf algorithms which can solve certain problems, which are claimed to solve certain problems and deal with all the inefficiencies and inaccuracies of those algorithms for our own instance, the ability to develop algorithms, define algorithms, and adjust existing algorithms to our own environment, I think is the more important ability for organizations. This also applies nicely to the problem that Jan mentioned. One of the important aspects of algorithms he mentioned that is adaptability of algorithms to different scenarios. I will take it a little bit further, and I would say, as change happens, which will happen in organizations, we need to be able to change the algorithms also. Not that we have only algorithms we can change based on changing environment, but as an organization, I should be able to adjust my algorithms themselves based on the changing environments easily and efficiently. So the correct question most probably must be, how can we come up with algorithms which are best fit to our own scenarios and situations? And how we can keep those algorithms significant and being able to handle situations as the situations change.
Thank you, Tamer. As you mentioned, algorithms are actually, adaptation in algorithms are very important, especially in today's world. And the algorithms, there is no fixed set of algorithms that can solve all problems. And over the years, they are adapting to new cases and new situations. There is also another side of adaptation, that is the organizational side. Because technology is changing not only our social interactions, but also our jobs and corporate-wide organizations. My next question is to Jan. Jan, how do you think this digital transformation and all the developments in terms of big data, data analytics, algorithms, and so forth impact organizations, required skill sets and capabilities in this manner?
Yes, that's a very broad question, Baris. That's a question that we can have a couple of webinars on, I think, and maybe also we should include then other types of people as well. So let me try to make it a bit smaller, because I think that the organization impact, I would like to start with, we have to do with people, with human beings. And if we talk about the digital transformation, I would like to emphasize two, let's say, conditions that are very important to make the digital transformation a success, without thinking about all stuff like change management, organization, different organizational structures, etc., just about the people, about the human beings. The first one is that when we want to move to a digital transformation, we must have people with an open mind. And what do I mean with this? I would like to refer here to a well-known four-stage competence model. And normally this competence model is expressed in four stages. It starts with you are unconscious incompetent. And so you are not aware of what you do not know, or you may even deny that you are not competent. The second step in that process is that, hey, wait, I'm becoming aware. I'm conscious of the fact that I do not know everything, and that I start to think, hey, wow, but I would like to know. And then the next step is that you learn and that you start to become competent, and that's an effort. And so it's an effort of will, it's an effort of energy, but you become competent. And in the end, after a couple of days or a couple of months or a couple of years, a bit depending on the situation, you become unconsciously competent. So you do the stuff that you are doing, and you do it in fact based on your intuition, or yeah, you are very capable. It's not costing that much energy, not that much will, you just do it. The interesting thing is that in the supply chain world, there are, of course, very many unconscious competent people, because we are doing our job and we are doing it very well, most of the times, not always, but most of the times. We have a successful company, the processes run well. So, in fact, we are quite happy with what we are doing. And now comes this idea of digital transformation. And then, of course, you must go back into the loop. You must be capable. You must have an open mind, and you must be able to say, okay, wait, there are things out there that might improve the way that I do things. And so this openness of mind is very important when you want to move forwards. That's one thing that you need. And so you need people with an open mind who constantly think about, okay, wait, I see there's stuff, I become aware of the possibilities, and I want to do something with it. And it's not only at the managerial level, but it's also at the operational level. That's one thing. The other thing in the digital transformation is that we have competent people, but then we have to bridge a big gap, a big gulf. That's the gulf between the abstract world of mathematics and information science. I call it abstract because for most people it is abstract, and the world of the concrete, of the people who are doing stuff, who execute, who take the decisions, who take the actions and do stuff. I think it's very important that we bridge this gulf between these two different types of human beings. But that implies that also here the people have an open mind towards one another. And so you both need a skill set, and the skill set is that they are curious for what the other people are doing, that they are together, that they collaborate, that they are creative, communicative, and that they show respect for the other. And when we have the people on the abstract and the concrete side who have these capabilities as human beings, that will certainly help in this digital transformation. And so for me, the base conditions for this digital transformation are that people need to have an open mind, and that they need to be able to collaborate with people with a completely different mindset. That's for me the starting point of the digital transformation.
Thank you, Jan. Thank you. Actually, this is an ongoing process, both from the organizational point of view and from the technological point of view. Here, actually, what can we expect from the future in this sense? Which technologies or methods do you expect to emerge and reshape the planning software market? My answer is both of you in this case.
Who will start, Tamer?
Let me start then, if you like.
Yeah.
I actually think there are basically there are a number of course, huge changes expected in planning software market due to technological change, cultural change, etc. But let me iterate three of them. I want to emphasize three occurring changes. These are not going to happen in the far future, but they are actually happening at the time. One of the things that I see is the move towards responsive decision making. What I mean by this is, as the data becomes a commodity, and as data becomes available more freely and more instantly, instead of batch availability of data, we can now, most data can be is accessible in an online fashion. So as this data flows in with more accuracy and more content, being able to respond, to understand what's changing in the system, and being able to generate response, especially optimal response to these changes, continuously record change in the system, becomes a crucial competitive requirement for the organizations now. You cannot just wait for the next day, for the next week to change your decisions. You have to respond to change in the system. You can record it. You can actually capture the change, and you need to be able to optimally respond to it. In this respect, algorithms need to play a very crucial role, because you cannot then always rely on human intuition and human processing of this information to generate this response. So you need to be automatically, algorithmically generate response to fast progress. In this respect, we have started using different tools of artificial intelligence to capture organizational events, assess organizational impact of these events, etc. in one end. And in the other end, once we make these assessments and categorizations of the current state, we can use, again, optimization algorithms or AI-based algorithms to actually generate optimal response to this stream of information. The second thing that I would like to mention is, again, is regarding the change, but this time, how can I capture and utilize change? So in the previous case, I mentioned that we need to be able to tap into the streaming data and changing data and try to understand what's changing and make optimized response decisions based on that thing. But you also need to do something even more in the coming years. It is to continuously assess risk and opportunities in the changed environment. One of the first things that we learned in the university when I started industrial engineering as an industrial engineering student, they told us that we are not solving natural problems. We are solving man-made problems. One of the ways that you can solve very difficult problems is by changing the problem rather than trying to find a better algorithm for an ill-defined problem. Now, this continuous change may actually also indicate that the whole structure for the business has changed, the risks have occurred, and there are certain opportunities that needs to be considered. So algorithmically, we need to be able to assess, continuously assess risk and opportunities in terms of the business and adjust the business parameters based on that. The third one is data is the soft value of decision making, as again Jan mentioned earlier. If you don't have data, it is very difficult to automate all these decision-making processes, etc. But in the this change is actually happening right now, and it's going to speed up, I think, in the near future. What we need to consider is look at our data and see if they are actually data. In today's ERP systems, most data are actually derivations of the actual data. Let me give you an example. For example, the bill of material. How do you generate the bill of material? In most ERP systems, you write your bill of material in your ERP systems in the form of data. However, if you have specific information, detailed technical information about your products, how they are, and algorithmic structures that describes how the production happens, why you use certain materials as components in those products, etc. So if you can capture the logic behind the structure of your products, you can actually think of bill of materials as a result of an algorithm. So you can actually write algorithms to derive bill of materials information from the source data. So we should make sure that what we call data occurs naturally. It is not driven, it is not generated, and we should capture the data in the source. So in all these things, what we can see is algorithms will become the essence of culture of organizations in time. They are going to be one of the significant assets of the company. So it is like the talent in the company. You have talented people placed in critical locations, making critical decisions, and that actually defines the culture and the competitiveness of your organization. The same thing, the algorithms will be placed in a similar role in the organizations. And the ability to maintain and adjust algorithms in the face of change will become one of the competitive weapons for the companies, I think, in the near future.
Thank you, Tamer.
Shall I add in a couple of minutes? Yeah. I think that when we look into the near future, in fact, what we see happening is that we move towards, let's say, virtual supply chain models, and we might call it a digital twin. That's on the one hand, and the other hand is that the algorithms that we were talking about will become more and more intelligent. So we also move towards artificial intelligence, and in fact, what we will see then is that we will integrate all the stuff that Tamer started talking about in the answer on the first question, what are algorithms? Those will all be integrated in this digital twin of the supply chain to grab the data from everywhere. It has the algorithms available to do both the description, as Tamer called it, the prediction and the prescription. And it will really then support people in everything that they do. And this is something that we will see developing, already see developing at many spots in the supply chain. So we have already virtual fabs, we have virtual distribution centers, we have virtual transportation networks, and these will be integrated into one big digital twin of the supply chain. I think that's also something that will happen in the near future. The technology is there, so it will certainly happen.
Thank you, Jan. So actually, if I may say, one takeaways from each of your future projection, what Tamer mentioned was very interesting. It was about having the master data being generated by algorithms instead of keeping the master data like bill of materials in rigid tables. Giving the responsibility of the generation and the maintenance to algorithms was very interesting. And the digital twin, actually, which is actually a very interesting topic because we have the ability in today's world to digitize many of the business processes and then create a twin scenario based on to manage the real life dynamics. Considering the time left, I may ask maybe one additional question. to you both. It's related to what you just described, both the digital twins and then the adaptive algorithms. We are, especially in the recent changes in both business life and economic life, uncertainty and disruptions in business processes, they have been a main concern for decision makers. So what can the algorithms learn from this process? So how can the existing algorithms or the previously placed algorithms or decision support systems can learn from the recent disruptions? Would you like to start?
That's a good question, Baris. You are, I think, also referring to what has been happening over the last couple of months, of course, the disruption that we have seen in the world. And the fact that then people go back to their drawing tables because they really need to think about, okay, how are we going to deal with this? There is so much happening. And how are we, from our business perspective, doing the right things in the right way? And of course, the first reaction is then, okay, well, that what we have at this moment is not really working very well. So if you talk about algorithms, maybe we should just dump the algorithms and start on a piece of paper and think about, okay, what shall we do? I think that's what many people have been doing, and it's a logical way of doing it. And of course, it is one of the things that we have been talking about earlier. It is one of the dangers that you have with, let's say, systems that are based on algorithms that have not been really thought through, also in the sense of, are they robust for changes? And that's something that we really need to work on. And so there are the small changes. Most algorithms are very capable of dealing with small changes. That's called forecasting, pattern recognition, and stuff like that. But disruption type of things, that we must really think to. This risk part of that Tamer also just mentioned. This risk part, how are we going to deal with risks?
Mm-hmm. And opportunities.
Question, and I don't have the answer ready yet.
Yeah.
Maybe Tamer has a start of an answer.
As you know. Now, this goes back to actually our discussion regarding the adaptability of algorithms. I think when you look at algorithms as in the recent years, in the last maybe 3-4 years, algorithms based on data has become the hot topic. You can take any data and you can put some Python libraries and you can estimate anything, or you can drive any results out of that data, categorizations and all sorts of algorithms. And this started looking like we actually have algorithms which can look at the data and understand what's going on with the data and repeat what is nicely done in the past based on the future scenarios. But this last crisis, in a sense, has pointed to us that not always the historical data represents what is the best that can be done in the future. So this actually, I think, needs to change our look at what algorithms should be doing, what learning means at a very detailed level. Because by just looking at past data and deriving categorizations and estimations out of that data is not enough anymore. Your algorithms should include the dynamics and the logic behind the supply chain environment, or in general, the world, basically. And since that can change, as we have experienced, we need to be able to generate systems, develop systems where we can immediately, instantly, very effectively change our algorithms' behavior, our algorithms' constraints, our algorithms' running environment, etc. So that is, I think, one of the things that became very apparent to me. So the way we look at algorithms has changed considerably. Should change, basically. As Jan mentioned now, anything that's based on historical data is useless now. Nothing looks like the last year, the last month, the last 6 months, whatever.
Thank you, Tamer.
So we should be able to, our algorithms should be able to capture the dynamics, not repeat what we have done previously. This is very much in line with what Jan mentioned about the organizational change, actually. The algorithms which are based on historical data is like a person who has experience, who has done the same things over and over again, and he has unconsciously makes decisions, and unconsciously he makes optimized decisions over and over again. And that has changed, like in the organizational structure. So the algorithms need to be able to stop and reconsider what they are doing. I don't know if they will be able to do it, Jan, but and maybe do things in a different manner. But that algorithmic adjustability is critical now.
Yeah, and I think just add one sentence to that. I think it's also very important what I mentioned about the organization. It needs then also the collaboration between the mathematicians on the one hand and the information science on the one hand, and the managers and decision makers on the other hand. That will also really help.
Yeah.
Thank you. Some final words, and actually, first of all, I would like to thank you both for sharing your really valuable experience to us and to all the audience. Actually, we had quite a crowded group of audience attending this webinar from all around the world. That's actually also very pleasing for us. Thanks to you, and thanks to all of the webinars for being a part of this very interesting webinar. Any final words from you before the closure?
Thank you very much, Paris, for moderating this webinar. It was a pleasure. Thank you.
Thank you. Hopefully we will continue in the next webinars. Yeah, and stay safe, everybody. Yeah. Goodbye.